Electron affinity EA is the fourth periodic trend that you need to know for this class. Affinity means to love. Therefore, electron affinity means to love electrons. It is the ability for an atom to take an electron at the gaseous state. So you could think of it as the opposite of ionization energy. Remember, ionization energy, we removed an electron, so the electron was present on the product side. For electron affinity, we are adding or taking in electrons, so the electrons appear on the reactant side. In general, non-metallic materials like to attract electrons, or they have an affinity for electrons. So they have high electron affinity values. When nonmetals take in electrons, it is an exothermic process. Metals have little affinity for electrons, so they have very low values or no values. That is why metals are usually cations. One thing I would like to note, your textbooks gives electron affinity in the positive value, but if you read carefully, it tells you it is an exothermic process. If you look at the table below or in your textbook, there is many exceptions to electron affinity. For this class, you need to only note one important one, that is chlorine. If I look at chlorine, it has a value of negative 349, even though fluorine is more non-metallic. So what is causing chlorine to have a higher electron affinity than fluorine? If you take a better look at the periodic table, you will notice the elements in the P block that are on the third period have a higher value of electron affinity than 2p. What is causing this? Energy level 2 is closer to the nucleus, so the atomic size of all the elements in energy level 2 are going to be smaller than the elements or the atoms in energy level 3. Energy level 2 is closer to the nucleus than energy level 3. It is more difficult to attract an electron in n equals 2 because the valence electrons are so close to each other that there is more repulsion from each other than energy level 3. The exception for electron affinity is EA is the highest for chlorine. The general trend for electron affinity follows the ionization energy. As I go across left to right, electron affinity increases because there's more protons, stronger the attraction, while electron shielding remains constant, so there's a higher effective nuclear charge. Down the periodic table, electron affinity decreases because it's further away from the nucleus, more energy levels, more electron shielding, more electron repulsion, so effective nuclear charge decreases. The only exception you need to know for electron affinity is chlorine is higher than fluorine. And just follow the general trend. We are not going to do all the exceptions. So for the following, pause the video, find the highest electron affinity, and then check your answer. For A, we have INTEFAR. See if they are in the same period. If not, see if they're in the same group, or see if there's a commonality. IN and TE are in the same period. IN is going to be smaller than TE. Electron affinity increases going across, so we know IN is not going to have the highest. As I go up the periodic table, electron affinity increases. Fluorine is much higher than TE. Fluorine is going to have a higher electron affinity than beryllium. And AR is a noble gas, and majority of the noble gas do not have an electron affinity because already have a full valence shell. My highest element should be fluorine. B, we have ClFibr. They are in the same family. As I go up the family, electron affinity increases. So my highest one should be fluorine. However, remember, fluorine atom is too small to take in another electron. Chlorine is the element with the highest EA. This is the exception to the rule that you need to note. So PSARAL, they are in period 3. As I go across, my electron affinity increases. AR should have my highest, but since this is a nonmetal, its valence shell is already filled, so it doesn't really want another electron. It's going to be sulfur. In D, we have KLiCsNa. These are in the same family. As I go up, electron affinity increases. The highest element on top is lithium, so lithium has the highest electron affinity. The last trend of the periodic table is electronegativity, En. This is different from electron affinity. Electron affinity is the ability to take in electrons to form ions. Electronegativity is the ability to attract electrons when it's bonding. The trend is the same as ionization energy in electron affinity. As I go across from left to right, electronegativity increases because there's more protons, stronger the attraction, while electron shielding remains constant. So there's an increase in effective nuclear charge. Electronegativity decreases as I go down the periodic table because it's further away from the nucleus. There's more energy levels, there's more electron shielding, and more electron-electron repulsion. So effective nuclear charge decreases. So you are already provided a table like this with all the electronegativity values. Fluorine has the highest electronegativity value because it's the most non-metallic character. So when it bonds with element, it wants the bulk of the share of the electrons. The metals, francium has one of the lowest because it is the most metallic character. It bonds with elements. It wants to give away the electrons. For the periodic trends test, you will not be provided this table. However, in the upcoming unit on VSFIRS, you will be provided a table for the test. So pause the video, rank the following in order of increasing electronegativity, and then check your answer. So determine if they are in the same period or family, or if they have something in common. We have BR, CA, and GE. They are in the same period. As I go across left to right on the periodic table, electronegativity increases. So increasing order is from small. So my smallest one is going to be on the left side. That's going to be calcium, then GE, and then BR. B, we have SR, RB, BE. They are not in the same period or in the same family, but they do share something in common, that is SR. As we go across left to right, En increases. RB is going to be smaller than SR. SR and BE are in the same family, and as I go up the group, it increases, so BE is going to be the largest. C, we have SIF, N, and O. F and O are in the same period, and as I go across, En increases, so the highest one is going to be fluorine. After fluorine, it's going to be oxygen and nitrogen. Silicon is one energy level below, so it's going to be a little bit lower, and so it's SiNOF. D, we have H, He, and Na. H is what they have in common. H and Na are in the same groups. Electronegativity increases up, so that means hydrogen has a higher En than Na. H and He are in the same period. As I go across, electronegativity increases. helium is in the noble gases. Helium, neon do not have values for electronegativity because they are inert. They do not bond with other elements. So He has no value, so that's going to be the smallest. So the general trends of the periodic table are as follows. We have two that decrease as I go across left to right. Atomic radius and ionic radius decreases as I go from left to right. Please note ionic radius starts large for cations and it gets smaller, and then it starts large again for the nonmetals or the anions and gets smaller. The other three trends go in the opposite direction. As I go from left to right, they increase. This is ionization energy, electron affinity, and electronegativity. The reason they either decrease or increase is the same reason. There is an increase in effective nuclear charge because there is more protons as I move from left to right, while the electron shielding remains constant. And the shielding remains constant because the electron shielding is provided by the core or the inner electrons. Since they are at the same energy level, the number of core electron is the same for all of them. As I go down the periodic table, the atomic radius and ionic radius increases. However, the other three trends go in the opposite direction. So as I go down the periodic table, they decrease. This is the ionization energy, the electron affinity, and the electronegativity. And all of them, they decrease for the same reason. There is a decrease in effective nuclear charge because there is more energy levels. That is the N. There is more electron shielding because as I increase an energy level, there are more core or inner electrons. Because there are more electrons, there's more electron-electron repulsion. This is the most metallic, and here is the most non-metallic. Diagonally, there is going to be a decrease of atomic and ionic radii, and there's going to be an increase in the other three trends, the IE, ionization energy, electron affinity, and electronegativity. Again, for this test, you need to note the general trends and the exceptions that are discussed in class or on this video. We are not doing all the exceptions.